Good morning, Townview. Welcome back to Chemistry Online.
So today we're going to be talking about nomenclature that includes polyatomic ions and transition metals. Before we do that though, we're going to start with some practice. So I'm going to run through these with you guys. So over here we have binary ionic, which means that there are only two elements involved. And when there are two elements involved, those are going to be the simplest ones. What we're going to do is so over here with the first one we have magnesium. And then here we got sulfur, that's just going to be sulfide. Next one we have potassium. And then oxygen, that's going to be oxide. And then here we have calcium. And F is going to be fluoride. So as you can see, the numbers that we have here don't actually matter when we're going from formula to name. So let's go ahead and look at this next portion. So here we have calcium chloride, that's going to be Ca and Cl. And here we have to plug in charges. So chlorine has a charge of -1, calcium has a charge of +2, which means we're going to need two chlorines for every calcium. So our formula is going to be CaCl2. So you could also just crisscross these. So you would put a 1 here and a 2 here, and then we never write in the ones when we go to formula. All right, next one is going to be strontium phosphide. So strontium is going to be Sr, and then phosphide is going to be P, that's just phosphorus. So strontium has a charge of +2, and then phosphorus has a charge of -3. So this is the best place to crisscross. So the 3 goes here, the 2 goes here. So Sr3, P2. And the next one, cesium nitride. So cesium is going to be Cs. It's got a charge of +1. And then nitrogen has a charge of -3. So again, we crisscross. So the 3 goes here, the 1 goes here. This becomes CS3N. And that's it. Those are binaries. Those are the easy ones. Let's go ahead and move on to ionic with polyatomic. So this time we have polyatomic ions, and then that's where we're going to use our polyatomic ion sheet. In this case, we have them written right here on the side. So again, we're just going to write out the name of the metal. For the first one, it's going to be magnesium. And then NO3 is going to be nitrate, so magnesium nitrate. We never change the name on polyatomic ions, so keep that in mind. So K2SO4, that's just going to be potassium. And then SO4 is sulfate. And the next one is going to be calcium cyanide. So again, when we're going from formula to name, the numbers don't matter here, and we don't change names on polyatomic ions. For the next one, here we have calcium and phosphate. So phosphate is going to be PO4, and it's got a charge of -3. And then calcium is going to be Ca, and it's got a charge of +2. So this is the best place to crisscross. So it's going to be Ca3, and then PO4 needs to be in parentheses. So anytime you multiply a polyatomic ion, you got to put it in parentheses so that you multiply the entire packet. So everything inside of here is going to be multiplied by 2, which means we have 2 PO4s. Next one is strontium chromate. That's going to be Sr, and then chromate is going to be CrO4. And then chromate has a charge of -2. And strontium has a charge of +2, so this is just a 1 and 1. So I'm just bring these closer together. So SrCrO4. And then last one, ammonium nitride. Ammonium is NH4, and it's got a charge of +1. And then nitride, so ending in IDE, that means this is nitrogen. So nitrogen has a charge of -3. That's just going to be N. So we're going to need 3 ammoniums for every 1 nitride. We put this in parentheses, put a 3 on the outside. So crisscross works here too. So the 3 goes there, and then the 1 goes here, but we never write out the 1s. And that's it. That's nomenclature with ionic and polyatomic ions. So next up we have our transition metals. So as you all know, these are going to be our transition metals. And then even though these metals down here, they fall under the non-metal section, these are also considered metalloids. So all right, so because the transition metals can lose more than one valence electron, we say about them that they have variable charges. And in the past, you would have to memorize different names. So for cobalt, if it had a charge of +2, you would call it cobaltus. If it had a charge of +3, you would call it cobaltic. And you can see here that this trend just keeps going on. So copper becomes copperous, or copperic. Gold is orus or auric. But this is the old naming system. We have a new one that you're about to learn today. So here we have iron and oxygen. So this becomes iron and then oxide. And then if we name this one also becomes iron oxide. So because we don't know the charge on iron, this classic way of naming doesn't work. What we have to do is we have to include the charge of the transition metal so that we can go from name to formula and formula to name. So we always know the charge of oxygen. That always has a charge of -2. And because we have one iron bonded to it, we know that we have a charge of +2, and we only have one iron. So this becomes iron 2 oxide. And we use Roman numerals. Over here, our oxygen has a charge of -2. We have a total of 3 oxygens, so our total negative charge is -6. Our total positive charge has to be +6. We have 2 irons. So we divide the 6 by 2. That tells us that we have our irons are going to have a charge of +3. Sorry, that should be +3 charge. So this becomes iron 3 oxide. And then to go the opposite way, so we know that we have iron. So here's Fe, and we have oxide. And here it says that our iron has a charge of +2. So this number in Roman numerals always tells you the charge of your transition metal. It's got a charge of +2. Our oxygen has a charge of -2. So that's it. That's our whole formula. Over here we put in Fe, and then we bring out the O. And then we know here that our oxygen has a charge of +3, and oxygen has a charge of -2. So we just crisscross. The 2 goes here, the 3 goes here, and there's our formula. So those are the rules for naming transition metals. The mistakes that are most commonly made are students would plug this in as the number of transition metal that they have. For example, iron 2 oxide, students would choose iron 2 oxide. And iron 3 oxide would be iron 3 oxide. And this is where the mistake comes from. You just got to keep in mind that that number tells you the charge of the transition metal, because that's the piece of information that you don't know. There are also exceptions to this rule. If you look at my periodic table, you'll see that they're labeled. So silver is always +1. So even though it sits with the transition metals, you don't treat it like a transition metal. So silver, which is Ag, always has a charge of +1. So let's say silver fluoride. We don't need to say silver 1 fluoride. We don't need to say this because silver is always +1. So this would just be silver 1 fluoride. Another such example would be zinc, which is always +2, and cadmium, which is always +2. So even though these metals, they sit with the transition metals, we don't include the charge in Roman numerals just because we don't need it. One other thing I want to discuss while we're on this slide is Roman numerals. So here are the numbers you need to know. So that's 1, 2, 3, 4, 5, and then possibly 6. There's 6 right there. So the ones you're going to see the most are going to be 1 through 4. These are the most common ones. However, I included 5 and 6 just in case you need them. All right, let's keep going. So you don't need anything from here. Here's our transition metal practice. Let's go ahead and solve these together. So first we have nickel. And we don't know the charge of our nickel, so let's figure it out. So we have NO3. NO3 is nitrate, and it's got a charge of -1. We have 2 of them, so we have a total negative charge of -2, which means our nickel has to have a charge of +2. We only have 1 nickel, so this is nickel 2 nitrate. Let's get the next one. So titanium, we don't know the charge of titanium, so we got to find SO4. SO4 has a charge of -2, which means titanium has to have a charge of +2. This becomes titanium 2 sulfate. Next one is mercury. And fluorine has a charge of -1, so total negative charge is -2. Mercury, this has to have a charge of +2. We only have one mercury, so this is mercury 2 fluoride. All right, so over here we have tin 4 sulfide. So tin is going to be SN, and the 4 tells us that it's got a charge of +4. Sulfide is just going to be sulfur, and sulfur has a charge of -2, which means we could crisscross this, so put 2 in front of tin and 4 in front of sulfur, but that won't work as the formula because anytime we have an ionic compound, we need to reduce it. So the better way to look at it is how many sulfurs do we need for every 1 tin, and that's just going to be 2. So it would be SnS2. If you had crisscrossed this, which that would be an answer choice on the test, it would be SN2S4, which is incorrect just because it would need to be reduced. And to reduce this, you just divide everything by 2, and that would give you SnS2. All right, next one is chromium phosphate. So chromium is Cr, and it's got a charge of +3, and then phosphate is PO4, and it's got a charge of -3, so this is just going to be a 1-to-1, so CrPO4. And then the last example we have is copper, which is Cu. It's got a charge of +2, and then hydroxide, which has a charge of -1, so OH, and then we put this in parentheses because we got to multiply it by 2. And that's it. That's your practice. So here we have some mixed practice. You can go ahead and work those out on your own. Here's some additional mixed practice, but I'm going to go ahead and stop right there with Ionic.
If you don't know how to do chemistry, hit that subscribe button. Let's